Hi, welcome back. We've now got to the final stage of this of the alignment procedure after the AM front-end alignment. So now what we need to do is basically the same as we did for the AM bands, we need to do for the FM bands. I think first of all, it's important to get an overview of what we're talking about. We have basically two sections here. The first is the actual FM front end. This section is inside that metal can, FM front end, which, as I've said before on various restorations, we try to mess with as little as possible, okay? And I don't want to deviate from the norm on this restoration either. The first thing we've got to consider is that we've actually got pretty good FM, so anything we're doing here is just basically minor tweaking, and you don't want to mess something up more than you correct. So you have the FM front end, and that's producing a intermediate frequency signal, which is FM modulated, and in this case it's 10.7 megahertz. Now what the signal does is it comes out of there, out of the can, through an IF transformer inside the can, which basically filters everything out except the 10.7 megahertz band. And that comes into this ECH81 through the selector switch when you select FM. We're going to look closely at this. I'm just giving the overview first. That signal gets amplified and comes out of the ECH81, goes through this first IF transformer. That first one is inside the can. This is the first IF transformer for the FM. It's inside the similar can, the same can as one of the AM IF transformers we optimized. It then goes into this tube here, the EBF89. It gets amplified, it comes out again and goes to this second IF transformer. And it then comes out of that second IF transformer into the EF80 tube. And this EF80 tube is now separate from the AM circuits. If you recall, the AM ended before this tube. And that last tube then it amplifies it as well, and it has the last IF transformer. And this last IF transformer is in a separate can by itself, which we're going to look at in detail in a second. Okay, so the thing to do here, the way we are going to adjust the alignment of these coils, of these transformers, is we need a 10.7 megahertz carrier signal. In this case, it's actually not modulated, and it's 10.7 megahertz because we know that's the IF frequency for this radio, and we need to pump that in at a particular point, which in this case is on the first tube. This first tube is the ECC85. And the way it's coupled is it's supposed to be very lightly coupled, and the way we do that is by just basically connecting the signal to something that will radiate into the tube. And I will show you what I use. I use a small coil that I've created which fits over the tube, and that then receives the 10.7 megahertz carrier unmodulated. This signal then mixes, if it was a normal RF signal, would mix with the oscillator frequency that's created on this tube. It acts as an oscillator and mixer, and we're not going to go into detail there, but the result is that at this point this coil, which is part of this IF transformer, becomes the load for this signal being generated inside this half, this triode of the ECC85. And that 10.7 megahertz signal is filtered, or rather that transformer is tuned to allow that 10.7 megahertz signal to pass, come out here, and into that switch, which is the selector between FM and AM, and into the grid of the ECH81. The signal coming into this grid gets amplified. In this case, the ECH81 is not operating as a mixer for the oscillator, local oscillator frequency, because that's only on AM. In this case, it just acts as an IF amplifier, which then comes out of the anode through there and then resonates on this IF transformer which we then tune also to the 10.7 megahertz. So this is the second in line for adjustment. The procedure basically repeats itself. It comes out of there, that becomes the source of the signal now, 10.7 megahertz, with a little bit of bandwidth. You want some bandwidth there, usually about 75 kilohertz either way of 10.7. But that signal comes through into the grid of the EBF89. It gets amplified, comes out of the anode, and the same thing happens again. This transformer then is tuned to allow the same signal to go through. Now, this final stage is a little bit more complicated because the signal comes in here into this EF80 and it gets amplified, and you have then the final IF transformer with the discriminator in it. And the way this works really is that you tune part of it. This part of the transformer gets tuned to the 10.7 megahertz, just like the others were done. And the last one is tuned to balance the discriminator circuit across that tuned part of the frequency band, so that you get the actual FM demodulation happening, and that FM demodulated signal is really your AF signal, your audio signal, which comes out of here, down here, and comes down here, into here, gets selected, across here, and if you recall, when it goes in here, it's AF. And this is where the selection happens between radio and the pickups. So basically what happens inside this can is that you're tuning the IF frequency, but you're also tuning the discriminator. The difference here and the difficulty in this particular case is that what you normally do, the way you normally tune your IF frequency, is you feed in that signal at the first ECC85, as I mentioned. You lightly couple the signal, and the way you measure the tuning is by measuring the voltage across this capacitor. This capacitor is an electrolytic, and you would measure the voltage across there, and normally this side, the positive side, would be connected to ground. So you'd measure, you'd put one lead of your multimeter on ground, which is normally the chassis, and you measure the voltage across there. It'll give you a negative voltage. It's an indication of the signal strength, and you would tune the coils to get the maximum voltage, negative voltage over there. The problem we have here, as I will show you in a minute, is that the can is completely sealed. This can here, I don't want to open it because it is working fairly well. And so it's rather difficult to get to this point there because this one is not connected to ground. It's actually creates a resistor, series resistor here with ground in the middle. Now, various ways of doing this, I suppose, and I'm really just guessing aloud here, I suppose you could connect your multimeter to ground and your other lead, the positive lead, to this point here, which comes out of the can, and you'd be getting about half the voltage that's actually across that capacitor. And I think that's what I'm going to do, because I don't want to dismantle that whole IF can to get to this point here. So I think that's going to be enough, and we'll find out soon enough. I'm going to set everything up. I'll show you where these things are, and then we'll try that. We'll try that halfway point to measure the half a voltage. What we're measuring here, really, with respect to ground coming out of this point, is the AGC voltage. So I think that'll be a good enough indication of our signal strength. If that doesn't work out, then I'm going to have to find a way of getting inside the can. Now I know that I've taken the top of the can off, and I can see this potentiometer there. Now, one side of this potentiometer is connected to that diode, the other side is actually connected to the top of that capacitor. So I suppose I could measure the voltage from that point to that end of that potentiometer, which is visible but not easily attachable. It's just sticking there. You can see it. I'd have to solder something on there. I'm going to try the simple route first, between here, or rather here, and ground, and see if we get our results. Now, we see a potentiometer here, and to the best of my knowledge, the way this works is you need a very balanced diodes here, this OA172. Ideally, they should be identical diodes, and identical in every way. They should be completely balanced. Now, because that is not quite as easy as it sounds to achieve, what they've got here is they've got a 220 ohm resistor. If these guys were perfectly balanced, you'd put a 220 ohm resistor over there. Because you're not sure that they're balanced, you make it a variable resistor. So I believe that's set properly, but we can always check it. We can get to that point. The one thing you have to be careful with here is because of the coupling that you've made on the front, it's a light coupling. Any movement can actually adjust or change the signal strength. All sorts of things can vary here. So the idea is leave well enough alone. We'll see if it's well enough, and then we'll carry on from there.
According to this drawing, which we're going to assume is correct, we have the first IF transformer, the second IF transformer, and the last one, which just houses the FM. It does not have these coils Roman numerals 1 and 2 for AM on this one. So we're going to start by this particular one here has the discriminator coil in it, and the primary is actually underneath. So what we're going to do is we're going to detune the discriminator one completely. Okay, that's what you normally do. You detune that discriminator one completely, and then we're going to start aligning this one here, and then we're going to go back to this one and that one, and then we'll go back to that one and that one, and then of course we've got to go to the one that's inside the IF can. And again, according to the drawings here, the two coils inside the IF can are G and H. So we're going to test to see if those are correct. You do it by adjusting them very slightly, see if you see a difference, so that if you got the wrong one, you can actually put it back where it was. But I think it'll be the right one now, okay? So we'll get the signal generator at 10.7 megahertz. Switch that on. And we have to do the light coupling to the ECC85, and that's done with this guy like that. And I will detune this one here. Just detune it quite a bit. Now, if I look at that transformer, I know that that's the 47k resistor that's coming out. So that's where I'm going to measure it from. Put the positive of the meter on there. The negative of the meter is just going to go to chassis. Now put the radio on, FM, and we're going to see what happens to this voltage over here. It should start climbing, or rather dropping negative. I'll put the tuning somewhere in the middle. It's not important. I'm getting a hiss on the other side, but I can actually turn the volume off. That's also not important. Now what I need to do is drop the amplitude of the signal from the signal generator, probably to about half of this. Well, let's leave it at 4. We don't want it too high because we don't want the AGC to step in and affect the readings. So we've got 3.3 volts minus 3.4 volts, and I'll just make that less sensitive. And now I'm going to start at the last one and try and peak it. It really is bouncing everywhere. I'm going to give it a bit more signal. See if it stabilizes. That's about it. Not much adjustment necessary there. Now we'll go to the one before that. You see that I've done nothing and it changes. It's also got to do with the fact that this thing's lightly coupled. So I've got to try not to move. That seems to be about it. I'll go to the top one. This is really very, very sensitive. I think I'm going to try a different way. What I'm going to do is I'm going to do it one stage at a time. I'm going to actually not lightly couple. I'm going to actually feed the signal into the previous tube's grid. So in this particular case, I'm tuning the last IF. So I'm going to feed it. The ground goes to chassis, and I'm going to feed it to the grid. That's AC coupled, so I'm going to feed it to the grid there. Give it a bit more signal because now there's no amplification. And so what I'm actually doing is just doing the last stage. Let's leave it at that. Try again. That's about it. Now I'm going to go back one and feed it to the grid of the previous one, of the previous tube. I'll have to drop the signal quite a bit because there is amplification in between. So I start low, and be careful you don't short anything out when you do this. See, it's a bit too high. Let's get the signal lower. There we go. Now we'll do this one again. I think I got the wrong one there. That's about it. Let's do the top one. That's it. Now I'm going to go back one more and feed it to the grid of the ECH81. So instead of putting it, doing the lightly coupled bit, I'm doing it one stage at a time, moving backwards. Okay? Again, I'm going to have to make the signal very small because the ECH81 does amplify it as well. As you can see, let's leave it there. Now we do that first one. That seems to be about it. It dropped when I remove this, although it is a wooden stick. That's about it. Let's go to the top. That's about it. Now all we need to do is we need to do that front end, which we need to actually do the lightly coupling bit, because now we're actually going to tune the IF transformer that is inside the can. I actually have to give it a bit more signal, otherwise it bounces around everywhere. It's pretty much there. Yep, that's pretty much it. Now we need to do the final one, which is that the discriminator, or rather the ratio detector. That's what we're going to adjust, that final secondary, and that is the strange one. Now the way to do that is there's a way you use two resistors in series, branch off the center of that. There's all sorts of ways of doing this. What I prefer to do on this one is I'm actually going to send out a frequency modulated sine wave, and I'm going to listen to it, look at it on the scope, and then adjust it for the least distortion, because that's really what you're doing. So we'll try that. Let me flip this over and we'll try that, see if we can get that done that way. So what I've got now is I've got the lightly coupled signal coming into the ECC85. I have a 10.7 megahertz carrier with 600 Hz FM modulation on it coming out of the signal generator, and I've connected the scope to the output, in other words to the speaker, and I should see the signal. Now I've got a pillow over the speaker because I need the volume up, but as you can see it's pretty distorted. Now I'm going to go back here and start tweaking this guy. And it's doing something. There we go. And I've got a clean sine wave. If I go the other way, if I go further, it distorts the other way. So I need to get it to the point of minimum distortion, which seems to be about there. And that's it. Now the important thing is to see whether this thing receives the stations properly. So let's try that now. So now I've got the FM antenna on the back and I've got it tuned to a fairly strong station.
Aos seus clamores e indiferentes aos seus desafios.
There we have it.
É preciso viver a imensa experiência de ser povo, a experiência de pertencer.
Very good quality sound.
Temos de entrar.
Let's try another one.
Inside my arms, it goes electric, baby, when I turn it on.
Yep, we've got it.
Caminho pastoral. Também a missão não termina aqui nem agora. Este é apenas o início.
And we've got FM.
Etapa de caminhada.
Brilliant.
Nos desafios por Deus semeados no íntimo da vida de cada de nós.
I know that's a roundabout way of doing the discriminator coil adjustment, but it works. As we've seen, we did something slightly different there when we did the actual alignment. So I just want to show you in more detail what exactly it is that I did do there. First of all, we put a voltmeter over here, negative to ground, positive to this end of that capacitor. Okay, that's the voltmeter we were looking at. And then the first thing we did is, because we didn't want to take the signal right from the first tube in the IF can, we actually fed it in somewhere else. We fed it in here, literally into the grid of this last tube. And the result then is we're actually looking at this signal path. And what we aligned then was this transformer here, the primary, okay? That was the first step. Once we had that first step done, we went one step back and we then fed the signal into this grid
over here of the EBF89. And so we are looking at this signal path. And to do that, we then tuned the primary and the secondary of that IF transformer. Then we went yet one step further back, and we fed the signal into the grid of the ECH81. And the signal path then was that one, and we aligned that IF transformer. So we're basically going backwards from the output all the way back to the input. And then finally, we fed the signal in, lightly coupled to that tube, and we were looking at this part of the signal, and we were aligning that final coil, which is that one there. And that's how we did the IF alignment. Then what we did is we went back to the last IF transformer. And here what we were looking at is to align, to balance this secondary. We could have done it various ways, but because of this complication of having all these components tied inside a can, we basically monitored the audio output. Really what we did is monitored at the speaker output, fed in a FM modulated sine wave at audio frequency sine wave on the carrier of 10.7 megahertz. So what we should get then, if everything is fine and dandy, is we should get a perfect sine wave over here at the output. And that's when we aligned this last one. This is the discriminator coil of this ratio detector. I've been erroneously calling it a discriminator. This is actually a balanced ratio detector. And we aligned that for the least distortion possible, and that tells us that we've got this in the right position. And that, my friends, is the FM alignment, done in a rather strange way, I must admit, because this radio is different, and I apologize that I didn't choose a different one, but I had no idea really that I'd come across these problems till I got way into it. So we have our FM alignment really right from the beginning when our signal, our carrier signal, is picked up by this tube. It feeds through the respective circuits. It's actually mixing with something, but it doesn't matter because the 10.7 megahertz carrier is getting put through. And we finally went all the way through, and we got ourselves out at the audio section, which is really what we want to hear. We want to hear good FM radio. And that is it for now. There's one final stage which I'm not going to do. I'm going to warn you, I'm not going to do it. And that is the RF alignment of the FM, which is really just to make sure that when you put it on 88 megahertz on the dial, you're getting 88 megahertz tuned in. What I found is that this thing is pretty damn close. I don't want to mess with this front end more than I have to, more than I have already, because if something goes wrong there, I'm going to get myself into a lot of trouble. So I'll probably do a detailed RF alignment on a future receiver, probably something a little bit more normal. This one does have its quirks, and it doesn't have its schematic exactly describing where the positions are of each of these coils. Exactly. So far I've been lucky. I don't want to push my luck. So that's it for now. The next stage obviously is working on the body. I have to clean it up, check what needs doing, and the last video you'll see on this is when I finalize that job and put everything back in and do a final testing. Thanks for watching. If you like this, please subscribe. Bye for now.